Hello everyone. Today we are going to talk about geometric sequences. What are geometric sequences? Well, we had arithmetic sequence. I'm going to write an arithmetic. Arithmetic sequence we're looking like this. 1, 3, 5, 7, and so on, right? So we're kind of adding +2, +2, and kind of same number. What is geometric? I'm going to first give example of geometric sequence, and then you can try to guess what is geometric sequence. 1, 2, 4, 8, 16, 32, and so on. So how do we obtain the next term in geometric sequence? Well, go from here to here, it's probably +1, but obviously from here to here, +1 is not going to work. We actually multiply by 2. 1 by 2 is 2. 2 by 2 is 4. So a sequence which you obtain by multiplication by a same number is called geometric sequence. This same number is called common ratio. We are going to use letter R for it, R equals. And this is the first term as usually. So how do we get term number 2? Term number 2, it's term number 1. I'm just going to label it as A, okay? First term. Multiplied by R, right? Term number 3 is going to be A multiplied by R, term number 2, right? And multiplied by extra R, by extra 2. And term number 4 is A by R, that's term number 3. And multiplied by more R, because we kind of multiply by R every time we move. Well, guys, if you look at the structure of the term, you're going to see that here we have A multiplied by R, and the power of R here, it's like 3 R's. It's 1 unit less than the number. So it's n minus 1. For example, here is A R squared, right? Which is kind of 3 minus 1, and here is just A R. So general formula for the nth term of geometric sequence is A R to the power of n minus 1. Okay? Well, A is not necessarily supposed to be 1, can be anything, and R is not necessarily supposed to be a like natural number, can be actually anything. Now, guys, let's imagine that somebody gives me geometric sequence and I'm trying to figure out what is what in it. So my first term is 1, my second term is 1/2, and then 1/4, and then 1/8, and so on. And it's obvious that my A is equal to 1, right? But what is my R? How to find R? Well, what I know, to move from this term to this, I multiplied by R. So it's 1/2 multiplied by R is 1/4. What does it mean? That R is 1/4 divided over 1/2, or next term over previous term, right? This is next term, 1/4. This is the previous term. Okay, well, in our case, division by a fraction is multiplication by inverse, right? And we are going to simplify it and get 1/2. So here, my R is equal 1/2, and my formula for the nth term is going to be 1/2 to the power of n minus 1. Okay? Let me give you another example of a sequence. So I want you to figure out like what is going to be R. For example, 5, 15, 45, and so on. So what is R here, and what is the formula for term n? Think for 5 minutes, stop the video, and I'm going to solve it, of course. So how I'm going to solve it? I remember that R, it's a next term by the previous term. So 15/5, which is going to give me 3. So my R is 3. My formula is going to be A1, which is 5, right? That's A. And R is equal to 3, and power is n minus 1. Okay? Well, very good. Now, guys, as a sum of arithmetic sequence, we also have a sum of geometric sequence. So formula is a little bit more complicated, and kind of calculations of the formula is a little bit more complicated, but I think we can prove this formula, okay? So sum of first n terms of geometric sequence. Well, first n terms are going to look like this. Sn equals a, the first term, plus term number 2, ar, term number 3, ar squared, and the last term is going to be ar to the power of n minus 1. That's term n, but the power is n unit, 1 unit less, just because we start was like 0 power of r, right? Okay, so guys, we are trying to figure out this. What I'm going to do, guys, I'm going to multiply this expression by extra r. I'm going to write down Sn multiplied by r, and on this side too by r. ar square, you know, extra r everywhere, just increasing the power. And the last one is going to be ar to the power of n, right? If we increase the power by 1 unit. Let me write down the previous one and the last one. The last one is n. And this one, not represented here, but kind of. Now, guys, what I'm going to do, I'm going to take these two expressions and subtract the second expression from the first. What I'm going to have? Well, I'm just going to write down Sn minus Sn multiplied by r. Now, a is going to stay because there is nothing to subtract from it, but this term is going to cancel with this if I subtract this from this, right? This term cancel with this. And the last term is canceled before the last term here, but this term is going to stay. So we're going to have minus ar to the power of n. Now, what I'm going to do, I'm going to factor out Sn from here, 1 minus r, and I'm just going to write down a minus ar to the power of n. So to find the sum, that's what we are looking for. Well, I'm going to divide by 1 minus r both sides. Rn 1 minus r. And that's going to be a nice formula of sum of geometric sequence. So it's like sigma I from 1 to n, an, sum of geometric sequence. Well, looks a little bit crazy, but why don't we consider a couple of examples of how to calculate the sum, and then develop one more formula. Example, let's consider a sequence 1, 5, 25, 1, 25, and so on. The first term is 1, right? The ratio you multiply by 5, kind of obvious. So the term number n is going to be 1 by 5 to the power of n minus 1. That's my ratio. Imagine somebody is asking to find s of 10 terms. According to my formula, what I'll need to do, s of 10 terms is the first element 1 minus the first element by ratio to the power of 10, because that's n over here, right? And 1 minus ratio is 5. I'm just plugging in all these numbers into my formula, very kind of easy. The only thing is, come on, I even don't know what is 5 to the power of 10. I think I'm not going to multiply, and I'm just going to leave it. That's going to be a huge number, 5 to the power of 10. And 1 minus 5 is negative 4. Guys, what I'm going to do, I don't want to have minus in denominator. I'm going to bring it in numerator. Switching the sign of the terms. Okay. Well, I'm going to leave this number. That's supposed to be a huge number. I don't want to use a calculator right now. Okay, let's calculate the sum of another sequence. Example number, that was example number 1. Let's do example number 2. One more. Let's have a sequence 1, 1 over 2, 1 over 4, 1 over 8, and so on. Here, the first term is 1. The ratio is you multiply 1 by 1 over 2, right? Let's find the sum of how many terms? 6 terms. What is sum of 6 terms here? Okay, how to find? Again, we are going to use the formula. Sum of 6 terms is the first term 1 minus the first term by 1 over 2 to the power of 6, and here 1 minus 1 over 2. Well, what do we have? 1 minus 1 over 2 to the power of 6, and here in denominator 1 minus 1 over 2 is 1 over 2. 1 over 2 to the power of 6 is 1 over 2 to the power of 6, right? And here 1 over 2 can be represented as, use a calculator, 2 to the power of 6. Okay, 2 to the power of 2 is 4. 4 by 4 is going to give us 16, and by 4 more, it's going to give us 64. So guys, I'm going to just write down 1 over 64 here, divided over 1 over 2. We remember that division by fraction is multiplication by inverse. So 1 minus 1 over 64 multiplied by 2 over 1. Multiplication by inverse. Inverse of this is 2 over 1. So, well, bring it to common denominator. It says 64 minus 1 divided over 64 and multiplied by 2. Okay, 64 minus 1 is 63, right? Here we can cancel 2 and 2 and get 32. That's going to be our final answer. So that's 63 over 32. One more tiny formula for today, and that's going to be it. Guys, you see that when we have a ratio of geometric sequence less than 1, like 1 over 2, then this term is not a big term actually. 1 over 64 is going to be a pretty small number. So if we make the power or some number of terms even more in this sequence, we're going to have a very, very small term, which is not going to almost affect the final result. This is called the sum of infinite geometric series. Let me kind of develop the formula. Infinite. Is infinite geometric sequence. Well, it's 1, 1 over 2, 1 over 4, and it just does not end. And imagine that you want to add all these terms, like 1 plus 1 over 2 plus 1 over 4 plus up to infinity. If you want to have all infinitely terms, what is going to happen? Well, if you use a formula, we're going to have minus 1 over 2, that's the same ratio, r equals 1 over 2, right? To the power of n minus 1, not n minus 1, n divided over 1 minus 1 over 2. Well, what is going to happen to this expression? If you recall, this is exponential function, right? And if 2 to the power of x looks like this, 1 over 2 to the power of x, 1 over 2 to the power of x looks like this. And when x or n goes to infinity, this function goes to 0. The whole thing will go to 0. We're going to have 1 over 1 minus 1 over 2, which is 1 over 1 over 2, or 1 multiplied by 2 over 1 or 2. So actually, sum of these infinitely many numbers is going to be equal to 2. Interesting, right? General formula. So for Sn, we have a minus a r to the power of n, 1 minus r, right? For infinitely many, for S infinity, we're going to have a 1 minus r. This term, when n goes to infinity and r less than 1, will go to 0. So that's going to be a new formula. The new formula is even better than the old one, right? It just has less numbers and less calculations. Well, I think we can calculate something, one more example of calculations of something for use of this formula. Imagine that we have a sequence which looks like this. 1 minus 1 over 3, 1 over 9, minus 1 over 27, and so on. And somebody is asking, what is the sum of infinitely many terms of this sequence? First, a equals 1, right? We need a and r. What is r? By what we'll need to multiply 1 to get negative 1 over 3. Well, r equals negative 1 over 3 sometimes can be negative. Now we're going to just use the formula. S infinity equals a, which is 1, right? 1 minus negative 1 over 3. Don't forget, minus comes together with r. It's 1 plus 1 over 3. Sorry, and a little bit more. Bring into common denominator. That's 3 plus 1 over 3, which is 1 over 4 over 3. Or remember that division by a fraction is multiplication by inverse. That's going to give us 3 over 4. And that's going to be the final answer for this problem. Interesting, right, guys? So we have infinitely many terms, but eventually we are going to have a finite number at the end. Well, usually it works only when terms are decreasing, and not only decreasing, but decreasing rapidly. If they're not decreasing rapidly, the number is still going to be infinity. Okay, that's all about geometric sequences. You can solve some problems on searching A0 or the ratio using the formulas we had in class. Okay, and I'll see you next lecture.